today is my third attempt, so we'll review it and talk about all the things I did before that led me to where I am today. But today, let's get started because we have a lot of time when we're just sitting around waiting for something to cool. And I know when things are cooling off, you know, it's fun just to watch them cool off. But I can tell you about the things that we've been doing the past couple of weeks. All right, so let me get my safety glasses on. I've got 0.25 grams of magnesium metal here. Now, as you recall, and we'll go over the reaction, the magnesium metal reacts with hydrochloric acid. I've got about 10 milliliters of concentrated hydrochloric acid, and I'm very carefully add it slowly. Now, what's going to happen is it's going to be a reaction. This is an acid, and that's a metal, and this acid is going to eat that metal alive. Everything's going to react. All right, so let's see if we can get in close here and pour a little in there. Ooh! It's reacting. It's really quite hot. I don't know if you can quite see that. Let's see if I can move it up here. Find a place in the camera. Whoa! It's very hot. It's very hot. You can see the steam coming off. I'm going to set this right here. All right. I'm going to pour a little bit more hydrochloric acid in there. You hear that? It's sizzling. Let's see if we can bring the camera over close. We can get a shot of the inside of that. Acid is reacting very vigorously. Oh, see all the bubbles coming up? Now that's hydrogen gas coming off. And I'm smelling some hydrogen chloride gas, which is from the hydrochloric acid. Ah, look at that, look at that. The magnesium metal is almost completely gone. I'm going to add just a little bit more. So far, I've added about 4 milliliters of hydrochloric acid. Added about 7 at this point. Just a tad more. And I think I'm just going to add I've added about 8. I'm going to add all that hydrochloric acid to it. All 10 milliliters. And you can see that the magnesium metal is gone. It looks like water. Well, liquid water. But actually it's acid in water. So now what's happened is our magnesium has reacted and been dissolved in the acid, and it's formed a new compound. All that bubbling and fizzing that was going on, that was the production of hydrogen gas, which is one of the products. The other product is in the water that's in the evaporating dish. Actually, this is a crucible. We'll talk about that later. But it's all there. And now what I want to do is get that compound out. So I'm going to boil off all the water as I did in the previous experiment. So I'm going to take my lab burner, I'm going to light my lab burner, I'm going to boil off that water so that we end up with the magnesium chloride, which is the compound that we formed. So let's light our burner. There we go. Nice flame. Got this adjusted. Now I'm going to open up the lab barrel here. I'm going to turn it, twist it again. What I want to do is let air come into the bottom of the hole, all right, that little gap in there, and the air contains the oxygen, which makes a hotter burning flame. So I want to start off heating this gently, in the sense that I want to warm this up, okay? Get it nice and gradually heat it up. You don't want to expose it immediately to a 700-degree flame. I mean, that would just like crack the material, perhaps. We don't want to do that. We've already had enough problems trying to do this lab experiment, so we want to do this. Just warm it up, all right? A minute or so, and I can start to see it boiling now. So I'm going to bring my lab burner down there, and I've got my flame adjusted right about here. Let's turn this so I can possibly see it here. Oh, it's boiling. Let's see if I can bring the camera over so that you can see it boiling right now. Oh, well, you can certainly see the steam coming off. Now, I want to be careful. All right, I don't want to boil this so much, get it so hot that it starts to splatter material out. That's what I've got to be aware of. So I'm going to gently boil this off. I'm going to kind of perhaps hold the lab burner with my hand so that I can gently heat it. All right, kind of simmer, sort of like on the stove when you just turn down the heat because you bring it to a boil, but you want to keep it a constant boil, not too much. All right, because I don't want anything splashing out of my crucible. Remember, I got a compound that's in the crucible. Well, will be there, and I want to see how many grams of it I get. So, as you perhaps recall, maybe you don't, maybe this is the first time you've seen this, I took 0.25 grams of the magnesium metal. Oh, now, I can't be just talking to you. I gotta be careful. Some just splashed out, hit the table here, so I gotta be careful to keep an eye on this. All right, so it doesn't do that again, because I'm trying to see how many grams of magnesium chloride I'm going to get. I have calculated using chemical calculations, specifically stoichiometry. I have calculated that I should get 0.98 grams of magnesium chloride. Now, this is a little bit of liquid in there, and I'm just trying to, it's kind of just, every now and then it's sort of a violent boil, because what happens is vapor bubbles form, and they get bigger and bigger, and then they kind of pop and explode. And sometimes they explode, and some of that liquid gets thrown out of the evaporating dish. Yeah, okay. Try to keep it nice and easy. We got it going. We got it going. See what happens? I'm getting down. I've got less and less liquid. As you get down with less and less liquid, the material, the solid, starts to form. And it starts to get kind of thick and gooey. And it's kind of like if you tomato paste, not tomato paste, tomato sauce. If you put tomato sauce on it and you're heating it, it starts to, you can't control it. It's just these bubbles form, and sometimes they erupt in a violent explosion, and material comes flying out. I can see some material, white material, which is my product, up on the sides of this crucible. And I do see that I see 3 little drops that actually hit the lab table here. So I got to keep that in mind. That's going to affect what I'm trying to do. Because what I want to see is if I can get 0.9, how close I can get to 0.98 grams of magnesium chloride. All right, it's getting there. The liquid is sort of yellow. That's the hydrogen chloride. That kind of is coming out. Oops, chlorine gas. Perhaps. Ooh, all right. Getting really close to the end here. So this is where you got to be patient. All right. You just don't want to put the lab burner underneath and walk away because it. So when it starts getting really crazy, take the lab burner away, holding it by hand. And this part's perfectly fine to hold. Ooh, that looks nice. Yeah. It's looking good. It's looking good. Ooh. And you see that white product. It's kind of, every time I come in here and do this to a lab, I'm a little bit apprehensive. I'm excited because, I'm excited because I want to see if what I've decided to do and the changes I decided to make are going to work and I'm going to get better results. But also, I'm a little bit nervous, like, oh man, I hope it works. So that's what makes it lab exciting and fun sometimes. Is this is looking really nice. Now it's getting really thick. I don't know if I can really. I don't want to risk moving the camera. I got to keep my eye on this. All right, make sure it doesn't. Ooh, it's really thick. As soon as I get rid of all the liquid, I will try to move it. So now, it appears very little of the liquid is gone. See, we picture of it. I'll bring this over here. Now, it looks fairly good, so let's bring this over. See if I can bring this so that you can see it. Let's see, we can bring that camera in there. Oh, I guess. Not only am I the lab doing the lab experiment, I am the cameraman. All right, I do everything in this job. And so you can see that my camera work is not that great at the moment. But there it is. There's my white solid. All right. Now, as I come back here, set that up, I'm going to crank the heat up a little bit here. Because what I want to do, what I learned last time is, well, let's kind of, at this point, we can kind of start to talk about what have I been doing. If you recall, the first time that I did this with hydrochloric acid, it's just really crusty. Right now, what I'm doing is I want to heat it, get it nice and hot, and try to get off all that solid. Okay, I mean not solid. I mean all the liquid. I make sure it all gets out. Now, one of the things I can do, and I can be careful here, is I can take some crucible tongs, and I can kind of just take a glass stirring rod, kind of just scrape this a little bit so that I can break up the material. Okay, and the reason I want to do that is if any of the liquid gets trapped, you know, sometimes when you form this crusty, when something evaporates off the surface, you get like a crusty layer, and that builds up, and it makes it difficult for the liquid that's trapped underneath to get out. Sometimes you've seen, like, you know, it looks like it's dried mud, and you kind of break through the surface of the mud or the dried part, and you get into the gooey part. Well, that's what it is. And so I'm trying to heat this up. I'm moving this around, and I'm also crushing it up. I'm crushing the little pieces, because as you break it into smaller and smaller pieces, you're exposing more and more surface area, so that more opportunity for the liquid to evaporate. Right? And it's looking pretty good. So how I can tell is when I take out my stirring rod, if there's nothing really sticking on it. So if there was something sticking on it, I know that it's still kind of moist. Right? It's sort of like when you're baking. If you've ever made brownies or a cake, one of the ways you test to see if it's done is you take a toothpick and you poke into the cake, and if it comes out clean, you know the cake's done. But if it comes out a little bit gooey, you know that the inside there still needs to work a little bit. All right. So now, I got this really crushed up quite nice. And I'm making sure that nothing stays on my, oops. I say oops because as I go over this, it's very hot. Nothing's on my stirring rod. This looks pretty good. This looks dry. So let me turn off my heat, and let's talk about what's been going on. Now, I want this to cool off a little bit faster. So I don't want to leave it in this hot metal ring because it's hot. So I'm going to use my crucible tongs, and I'm going to bring it down and lift it off very carefully and put it on the table here on a wire gauze. And now we can wait for this to cool, which is fun. We can just watch it. All right, you can spend the whole time just watching this. Well, nah, we'll do that another time. Okay, so let's talk about what I've been doing. The first time I did this experiment, I was using a much weaker acid. When I say weaker, I mean less concentrated. Okay, so I was using a concentration of 1 mole per liter of acid, and it required about this much acid for me to react to make the 0.25 grams of magnesium that I had. And it reacted really slowly, really slowly. It took almost 16 minutes in that video for that acid to completely dissolve the magnesium. Then I was trying to evaporate this off. And now I chose a test tube because I wanted you to be able to see everything that's going inside there and see the reaction here. A little harder to see it inside this crucible that I ended up going with today. But so I was heating it, and I had quite a lot of liquid, and I was heating it gently, as you recall, going back and forth over the flame, and eventually vapor bubble builds up, and explodes out a bunch of my liquid, which contains a bunch of my compound that I'm trying to obtain. So that pretty much meant that I had to do the experiment over because I lost my material. So I decided for the next time I was going to use a more concentrated hydrochloric acid, which is the one I chose for today. All right, it was 10 molar, 10 times stronger concentration. And I only had to use, as you recall, about half of this, which is about 5 milliliters of acid. And it was about up here, and it reacted very quickly. In seconds it was reacted, just like what you saw today. So then I evaporated off that liquid, and it didn't take very long, because it was hot already from the heat that was generated from the chemical reaction. And I got the solid. But what happens is the solid formed all around the sides of the walls of the test tube. And I heated it for about 2 or 3 minutes. But now I didn't do what I did today, where I tried to break it up. I just heated it, and I took the mass of it. It turned out that I calculated I was supposed to get 0.98 grams of this material, and I got 1.27 grams of it. I got more than I was supposed to get, which meant my percent yield. Okay, I got more than 100%. I got 130%, which is more than you possibly can get. You can't get more than 100%. 100% you got everything you got. Everything that you were meant to get, you got it. You produced it, but you can't produce more than 130. So I left thinking, maybe I didn't heat it long enough. Maybe I should heat it a second time. So I went home, and I massed it again, and I noticed that the mass went up again. Even it went up to 1.33 grams from 1.27. And I was curious about that and began to do some investigation about what this, let me check, still really hot. So I can still tell my story here. This takes about 8 to 10 minutes to cool off. So I can continue with my story. So I looked up some properties of magnesium chloride. And it turns out it's deliquescent. Now, deliquescent means that it absorbs moisture from the air. And that might account for why it was getting heavier. So I decided to try to break up the solid, and I was going to heat it a second time. So because this test tube is so tall, I had very, very difficult time using this. It wasn't quite long enough for me to get in there. I ended up using this long screwdriver. I mean, this is not very scientific. A long screwdriver that I got from the garage, and I went in there and I broke it up and crushed it. And I went and heated a second time, and this time I got 0.7 grams. Excuse me, yes, 0.7 grams. And if you watch that video the last time, that works out to about a 71% yield. Okay, well, that's not bad. It's not great. I'd like to do better than that, but it's about 71%. And so I realized at that time that this was not, I wanted to be able to crush it up while it's still heating. And that's why I switched over today. Still a bit warm. I switched over to what's called a crucible. The crucible, all right, there are definite advantages of it. Okay, you can heat to high temperature. This is a fairly large crucible, so a lot of the material, and I can pick this up, it's still pretty hot, but a lot of the material is splashed up on the sides there. But I kept a lot there, and I was able to use my glass stirring rod and crush it up and pulverize the solid, so it wasn't big chunks of material. Because once those big chunks form, then it's really hard to get that moisture out, that water that's trapped inside. So this way I crushed it. So I'm going to get a mass of it now. After it cools, whoa, be careful. You don't want to spill it. When we come this far, we don't want to lose it now. All right, so here's what I've done. When you came in, I took the mass of that empty crucible. And the mass of that empty crucible was 74.57 grams. Then I added my magnesium pieces to it, and I got 74.82, which works out to be 0.25 grams if you subtract those two numbers. Okay? So what we're doing today is we're doing this reaction where, and as you see here, if I subtract those two, I subtract the mass of the test tube with the magnesium minus the mass of the test tube, I got 0.25 grams of magnesium. And what's going to happen is the magnesium here, Mg, is reacting with the hydrochloric acid, HCl, and it's going to form magnesium chloride, which is the white compound that I'm forming, and that bubbling that you saw, that gas coming off was hydrogen gas. All right, we calculated, and I calculated, and you can calculate using stoichiometry. For the 0.25 grams of magnesium, we calculated that the number of grams of MgCl2 that we're going to get is 0.98 grams. That's what's called the theoretical yield. Okay, so in just a minute or so, I'm going to get the mass of the test tube with my compound in there, the magnesium chloride. Okay, and I'm saying that this is the first heat because I would like to, I want to make sure this time it's completely dry. Now, this is cool enough that I can hold it in my hand. It's just a little bit warm, but I want to mass it now. Okay, I think it's time to get the mass. I know a lot of you would say get the weight of it, but as a chemist, as a scientist, we talk about mass. It's the amount of material something has. Maybe your physics teacher will explain to you the difference between mass and weight. Weight depends on the gravitational pull. So weight can vary wherever you go. So if you weigh yourself on the moon, you're going to weigh 1/6 the weight you are here. But if you get your mass here and there, it's the same. All right. That's another episode. All right, so let me get my lab balance on. Make sure it's zeroed. I'm going to put this on here. And 75.22 grams. 75.22 grams. So let me record that in my data table. 75.22 grams. And so at this moment, I'm just going to put that here. I have 75.22 grams of material. Okay, 75.22 grams. So if you subtract that minus that, we can see how many grams we actually got. Well, let me just do that real quickly. Get my calculator over here, or perhaps you can do it at home there. Let's see, 75.22 minus 74. This is the test tube's mass. 0.57 equals 0.65. 0.65 grams. Now, that works out to be less than what I was expecting to get. Well, maybe that's as good as it's going to get, maybe. I don't know. The question is, and you can decide this moment if you want to continue on watching this, is it completely dry? It looks dry. I mean, when we look at it from there, and it's hard to see with this lighting because it is white and a reflection, but it looks dry. But the question is, as a chemist, is it really completely dry? So you could stop watching now and use that 0.65 grams as what's called the actual yield, which you can record that there, okay, and figure out the percent yield. Got my fingers over there. The percent yield, which you take the actual yield, which would be 0.65 grams, divided by 0.98 grams, which is the theoretical yield. Multiply that answer times 100, and you should get the percent yield, which doing just a quick estimate, I'm guessing probably 66, 67% is what I got. Now, maybe that's as good as I can do, but the question is this really magnesium chloride? Is it dry? It does tend to absorb water. So here's what I'm going to do. I'm going to heat it a second time. And so if you want to stay on, we can do that. I want to heat it a second time because I'm curious. I want to know that I got it completely dry. All right, and I want to know that that's the mass. So I heat. What you do is you light your burner. You're going to heat it a second time for just about 2 minutes. All right, we just want to be sure that this is completely dry so that we can calculate exactly how many grams we got. And from that, we may be wanting to do other calculations because once we get the grams of this material, we can figure out the moles of it. That would be interesting. How many moles of magnesium chloride did we get? We know that we had 0.25 grams of magnesium, so we can know how many moles of magnesium we got. And we can compare them and see what's the relationship between the moles of the magnesium we started with and the moles of the magnesium chloride. So I'm heating this a second time. Now I've crushed this, I've broken it up, and I'm going to really heat it. And I want to go 2 minutes on this, which is good to have a clock. I forgot to bring one today. Doggone it. So, but I'm going to look at the clock over there on my laptop. 5. Oh, so I'm going to go 2 minutes, and then we're going to let it cool. Again, cooling is the part that's the hardest. But we can talk, okay? Or while we're letting it cool, we can tell chemistry jokes, perhaps. That would be fun. Anyway, let's see here. It's 5:08. I'm just eating this. Let me get it. I got a couple chemistry jokes I could tell you. Use the time. Okay. Let's get that nice. Now I'm going to take my crucible tongs, and I'm going to take my stirring rod, and I'm just going to kind of go around the edges here and just tap at it, break it up, get those little chunks into smaller pieces, and when they get to smaller pieces and smaller and smaller and smaller, then you get more and more of the liquid has a chance to escape. Well, it doesn't look like liquid, but there's water vapor there. Moisture. Water molecules, I should say, to be specific. But I want to expose those water molecules. I want them to be able to get out. All right. Because magnesium, the other thing about magnesium chloride is it has a tendency to hold on to water molecules. Specifically, for every magnesium chloride. All right, it's been about 2 minutes, so let's stop that. Now again, make sure that you haven't taken anything out of the thing. Turn off your gas. Again, we're going to let this cool on our wire gauze on the table. It'll cool faster. So, all right. So let's see. And again, using this technique, one of the risks associated with it is I got just a little bit of magnesium chloride on there. I don't know if you can see that very well, the white material there, but no, it's not very much. But you know, it's kind of a toss-up between, gee, do I not do that and get a better yield, but still have wet, kind of sticky stuff? I want pure magnesium chloride. That's what I'm trying to obtain. So yeah, I'd like to get a high percent yield, all right? Right now we're at about 66, 67. But when you're making a compound, you want to get pure compound. You want just the compound. And sometimes chemical reactions, the best you can do is maybe 60 or 70% yield, which means you're getting, okay, in this case, let's say I got 66%. That means I got 66% of what I was supposed to get. Somewhere I lost the other 34%. I don't know. Maybe that splashed out. Maybe, oh shoot. You know what? As I look at the table here and I see the liquid drops there, maybe look, there's some of my stuff. This is what happens when you're doing reactions, or when you're doing chemistry. I mean, so there's always going to be a margin, some margin or experimental error involved. So maybe perhaps using this technique, doing it in the way in which I've done it, 67% is as good as you're going to get with doing this, okay? And one of the things chemists do, I'm checking it out, it's still pretty hot. One of the things chemists do is they come up with different ways, or come up with procedures to increase the percent yield. Because that's what you want to do. Is, I mean, it would be nice if I could, instead of getting 66%, and I could get maybe in the 70s or 80s, because then I'm not wasting my material. I'm not losing some of it. Because that magnesium metal, that costs money. All right, so you got your product, you got the cost of what you're reacting, and you don't want to be wasteful and lose some of it, like I did here and got on the lab table. So you try to come up with ways in which to maximize the yield. And that's what a chemist does. And that can be fun, it can be frustrating, but it can be challenging and interesting because how can I do it better? Now, if I was doing this, and I'm not going to do it again, but really what we want to do is do this maybe 3 times and see what our percent yield works out to be. Because maybe 67% is about what it should be. Actually, it'd be kind of interesting for you to try it. Or if you have the means to do it, or we can try it again. But if I do it again, maybe 3-4 times, and I see that I'm consistently getting 66, 67%, then maybe with this technique, that's as good as it's going to get. All right. So, still touching it, feels a little bit hot. You can't take it when it's really, really hot like this and set it on your lab balance because, well, a couple things. Sometimes there's plastic components underneath, and the heat. I've got a metal top here, and the heat from this is going to go into heating up the metal, which might heat up the plastic components, and might ruin your lab balance. Then, well, also, a lot of times when it's very, very hot, there's hot air coming off the sides of it creates kind of convection currents, which can kind of alter the weight of the mass a little bit. So, while I got this time, I can give you this joke, chemistry joke. Because what happens here in this reaction with magnesium, this magnesium metal has an equal number of protons and electrons. And all elements do. And the protons have a positive charge, and the electrons have a negative charge. So a proton has a +1 charge, and an electron has a -1 charge. So if you have equal numbers, then that plus and that minus cancel, and you have 0 charge. In the case of the magnesium atom, it has 12 protons and 12 electrons. So those 12 electrons cancel the charge of the positive. So +1 -1 adds up to 0. All elements are neutral charge. Compounds that are formed are also neutral. So what happened to this magnesium is it reacted with the chlorine gas. The chlorine is another element. Chlorine is an element that has 17 electrons and 17 protons. So it reacted. And here's what happened. I'm going to tell it through this joke. Still kind of hot. So, 2 magnesium atoms are in a bar. One magnesium atom says to the other, I met these 2 chlorine atoms the other day. I think they took 2 of my electrons. The other magnesium atom says, you sure? He says, yeah, I'm doubly positive. And get it doubly positive? See, that magnesium atom had 12 electrons. But if those 2 chlorine atoms took 2 electrons from magnesium, then magnesium now has 2 more protons, 12 protons, and only 10 electrons, which means it has 2 more extra positives. It's doubly positive. And what happened to the chlorine? the chlorine, each chlorine atom got an additional electron. Remember, they have 17 electrons, so each chlorine atom got 1 electron, one more, so they have 18 electrons to go with their 17 protons. And that means they have a negative, extra negative charge, so they have a negative 1 charge. So that magnesium atom has 2 positive charges. Now, the thing about charges, plus and minus, as you've perhaps learned, opposite charges attract. So that plus charge of the magnesium is attracted to that negative charge of a chlorine. Well, that magnesium has 2 plus charges, so it needs 2 chlorine atoms with those 2 negatives, and they're attracted, and you form the compound magnesium chloride, which is what we came up with in the formula, MgCl2, because the magnesium has a 2 plus charge. Each chloride has a minus 1 charge, and so minus 2 plus 2 adds up to 0. So when you form compounds form, they end up having 0 charge, because the positive and negative particles have come together in such a way to cancel out the overall charge. That's what we got, magnesium chloride. Now it is cool enough that I can hold it, and that's usually the test to see that you can go ahead and mass it. So here we go. 75.13 grams. 75.13 grams. So, you can see, after the second heating, it went down quite a bit. It looks like it went down. 22 minus 13 would be about 0.08 grams. So it went down. Normally, as a chemist, what we do is we like to see it only go down less than 0.02 grams. So ideally, if we're really doing quantitative work, which means we really are interested in the exact amount, we would heat this a 3rd time. And hopefully it won't go down more than 75.11, or 75.12, or 75.13. That way we know that it's now completely dry, and that is the mass of the compound. But we're not going to do that because we've been doing this for almost 38 minutes. Can you believe it? 38 minutes. Wow, time flies when you're in the lab. But now you can subtract those. Of course, you've got to use that over here. You'll use a different mass here. You use the 75.11. So it looks like we're going to get, if I take away 0.08 from that, it's going to be 0.65 minus 0.08, about 0.57 grams. So 0.57 grams is my actual yield. Theoretical yield is 0.98. So it looks like I'm maybe about 58%, maybe 59%. Okay. So it's been fun doing this today. It would be interesting to see, do it 2 or 3 times to see what is what can you expect for a percent yield. So with that, as we approach the 39-minute mark, it's been another great day in the lab. All right, so you have a great day, because when we're doing lab, it's always a great day. See ya.